All right, let's dive right in, shall we? You've sent us a whole bunch of stuff about design patterns. Looks like you really want to get this, huh? Not just the what, but like the why and how to really use them, and that's what we're here for.
Yeah, design patterns are really cool because they're like ready-made solutions for those coding headaches we all get, right? Like instead of starting from scratch every time, you've got these proven blueprints. It makes your code cleaner, faster, easier to work with.
Blueprints. I like that. And I'm seeing that everywhere in these resources talking about reusable solutions and best practices. But how do these blueprints actually work in the real world? Like, what do they look like when you actually code?
Okay, so imagine this. Just like you use a blueprint to build a house, you can use a design pattern to solve a coding problem. Let's say you need to create a login system for your website. You could use a design pattern instead of writing it all from scratch.
So you're not reinventing the wheel every single time. You're using a system that's already been proven to work. And it seems like our listener really gets that, but they're also curious about why. Why are these patterns so important for developers?
One of the biggest reasons is that it helps everyone get on the same page. When all developers know the common design patterns, it's like speaking the same language, you know? Less confusion, better teamwork.
Right, like a shortcut for everyone. Especially important when you've got a big project with lots of people working on it.
Exactly. And it's not just about talking to each other better, it's about writing less code.
Yeah.
When you use design patterns, you can reuse chunks of code, which saves a ton of time and makes things less error-prone.
So more efficient, fewer errors, and everyone speaking the same language. Gotcha. Now, I'm seeing these sources break down design patterns into three main types: creational, structural, and behavioral. It's like having different tools in your coding toolbox, right?
That's a great analogy. Creational patterns are all about making new objects. Structural patterns are how you organize everything, and behavioral patterns are how those objects interact with each other.
Okay, so let's break out some of these tools. I'm curious about the singleton pattern. It's a creational pattern, right? Like, imagine you've got this one central point of access for something in your app, like connecting to a database.
The singleton pattern is perfect for situations where you only need one of something. It makes sure you only have one connection to your database, for example, which keeps things running smoothly.
So instead of different parts of your code making their own connections, you have one central connection managed by this singleton thing. Makes sense to me.
Right. And that way, everyone is on the same page, working with the same data, which prevents a lot of potential headaches down the road.
Okay, that's clear. Now, another one that caught my eye is the factory method, also a creational pattern. This one seems to be about making it easier to create different types of objects without writing a ton of code.
Exactly. Let's say you're building a game and you have all these different enemy types. Instead of writing new code for every single one, you can use the factory method to create a factory that handles all that for you.
So it's like having a one-stop shop for creating objects. Sounds pretty efficient, especially if you're working with a lot of different object types.
Absolutely. It makes your code way more streamlined and easier to update later on.
This is really making me rethink the way I approach coding. Okay, before we move on, there's one more creational pattern I gotta ask about. The observer pattern. It's basically a notification system for your code, isn't it?
Exactly. Think of it like subscribing to a newsletter. Whenever there's a new post or any changes, you get notified automatically.
So let's say you're updating data in one part of your app. This observer pattern could automatically update other parts that need that data.
You got it. It's a super useful way to keep different parts of your code in sync without them being directly connected. Really helps to keep things organized and efficient.
Okay, so we've talked about those creational patterns, right? But let's move on to structural patterns. I'm seeing this composite pattern pop up a lot, and I think it'll really click with our listener because it uses this file system analogy. Pretty neat.
Yeah, the composite pattern is all about hierarchies. Just like you have folders within folders on your computer, you can have objects within objects in your code. Makes it super organized.
So instead of writing different code for individual things and groups of things, you can handle them all the same way with composite.
Exactly. It's like having one set of rules that works for everything. Makes your code way cleaner and easier to manage.
Our listener will appreciate that for sure they're all about that clean code. Now, I'm seeing this word recursion come up a lot with composite. It's like the pattern can call itself, kind of like those Russian nesting dolls.
Huh, yeah, kinda. That's recursion in a nutshell. And it's what makes the composite pattern so powerful. Imagine you want to do something to every file in a folder, even the ones buried deep down in subfolders. Recursion lets you do that super easily.
Recursion, it's one of those things that makes you scratch your head at first, but then it just clicks. Super useful for working with those complex structures, like in user interfaces or big data sets.
Absolutely. Once you get it, it's a real game changer.
Now, another structural pattern that keeps coming up, especially in the front-end design world, is the adapter pattern. It's about making things work together that weren't really designed to, right?
Exactly. Like, think about those adapters you use for travel. You might have different plug shapes in different countries, but the adapter lets you plug in anywhere.
So it's like a translator for your code. You might have a piece of code that doesn't quite fit with the rest, but the adapter pattern makes it work seamlessly.
You got it. Super useful when you want to use a third-party library or some older code that might not play nice with your current project.
Really saves you a lot of headaches and rewrites in the long run. Now, we've covered creational and structural, so let's jump into the fun stuff. Behavioral patterns. And I think it's only right to start with the strategy pattern, probably the most well-known of the bunch.
Oh yeah, strategy is a classic. Basically, it lets you swap out different algorithms really easily, like switching gears in a car.
So instead of having all these if-else statements to decide which algorithm to use, you can just use the strategy pattern to make the switch on the fly.
Yep, you got it. This makes your code super adaptable because you can add new algorithms or tweak existing ones without messing with the core logic of your application.
Now, this reminds me of something I read in Design Patterns, a brief overview. They make a good point about the difference between an algorithm and a design pattern.
Right. A lot of people get those mixed up.
Yeah, like they use sorting as an example.
Yeah.
You have bubble sort, quick sort, and all those different sorting methods. Those are algorithms, right? Each one has its own specific steps.
Right.
But the design pattern, in this case the strategy pattern, is like the overall plan for how you organize and use those algorithms. It's a higher level of thinking.
That's a great way to put it. It's not about the individual algorithms themselves, but how you structure your code to use them effectively. And that's a key distinction to remember.
Makes perfect sense. Okay, another behavioral pattern that keeps popping up, especially in the front-end design pattern source, is the command pattern. This one seems a little abstract. It's about treating commands as objects, which sounds kind of weird at first.
It's actually pretty intuitive once you get the hang of it. Think about something like a text editor. Every time you type a letter, delete something, or change the formatting, that's a command, right?
Yeah, so instead of those actions being buried in your code somewhere, the command pattern lets you package them up into these neat little objects.
Exactly. And once they're objects, you can do all sorts of cool things with them, like storing them, manipulating them, even undoing and redoing them.
So basically, it's like having an undo button for pretty much anything in your app. Super useful. You know, it's funny, for something called design patterns, a lot of these sources talk about them in a much broader sense. Like, it's not just about writing code, but also about things like architecture, legal contracts. It's almost like a way of thinking, right?
Totally. It's about seeing patterns and finding elegant solutions that you can reuse. And that applies to way more than just software.
Yeah, it's like those architects we were talking about earlier using blueprints for doors and windows, or lawyers with their contract templates. It's all about standardizing solutions for a common problem.
Exactly. And by recognizing those patterns, you can work much more efficiently and make sure things are consistent. Heck, even a cooking recipe is kind of like a design pattern, a set of steps to get a delicious result.
Huh. I never thought of it that way. So learning about design patterns isn't just about being a better coder. It's about thinking smarter and solving problems more creatively in any field, really.
Exactly. It's a valuable skill to have no matter what you do.
Well, we've covered a lot of ground here today, haven't we? From the basics of what design patterns are, to how they're used in the real world, and even how they apply to other areas of life. Hopefully our listener is feeling ready to put all this knowledge to good use.
Absolutely. The key is to really understand the principles behind the patterns, not just memorize them blindly. It's about knowing when to use which tool for the job.
And even more importantly, it's about always looking for those patterns, those recurring problems, and finding those elegant solutions, whether you're writing code, designing a building, or just organizing your day.
Couldn't have said it better myself. Design thinking is a powerful tool.
It really is. So as you go out there and tackle those coding challenges, keep an eye out for those patterns. And who knows, maybe you'll even discover some new ones. That's all for today's deep dive. Until next time, happy coding.